go through and say is you pick one of the two, Emily. Which one do you want? Okay. Is that continuous? Look at you. Thank you, by the way, for picking the one easy. Bang out the easy ones in the beginning. John Paul, what's your second function? Now, I actually said it as x cubed by itself. You're not wrong, though. You could view it that way also. The reason that I tell you that is my notation then is probably going to be slightly different than his. Is the x cubed function continuous? Yeah, because any number you put in, you can cube and get an output. However, you correctly said 1 over x cubed. So is 1 over x cubed continuous? No. Where is it discontinuous? Perfect. So you can see why I did mine slightly different. That's why he's not wrong to say his either. I just viewed mine as the second function was x cubed, which would be continuous, except now since it's in the denominator, we get an issue. Now, is f of x continuous? Is f of x going to be continuous? Lily?
No.
Why? Yeah. It looks like she's cheating. So that is continuous everywhere except for that place where my denominator is going to equal 0. Do we have questions on that? One other thing, by the way, I don't know if they did this with you in pre-calculus. This was a topic that was removed from calc. Did they do composition of functions with you in pre-calc, meaning you take one function and plug it into the other? Maybe? Okay, if they did, great. If not, I just didn't want us to encounter a roadblock. Next one up, compositions of functions are continuous if the components are continuous. So this is where it's going to get a little bit dicey. Looking at that right now, f of x, I see, I guess when I start off, I always look for, there's a big function and then another function sort of plugged into it. This to me, and I don't know if you'll see it this way, I look at f of x, really f of x, in my opinion, is just a cube root function with something in the argument spot. So I'd start off and look at what's my h of x? Well, that's whatever we have on the inside here. I define in the beginning, oh, the outside function, I did it a little bit backwards here. Depends on how you confine it. The inside plugged in function, and then the outside one, this, I'm looking at the outside, I guess, first. Is the cube root function continuous? And the answer is yes. You can take the cube root of a negative number. What would our inside function be then also? Take a look what other function is contained in there, because I'm essentially plugging something in to the cube root parent function. What did I plug into the parent function to get out that f of x? Look at what's there. What would we go through and say, Caleb? What function did I plug into that cube root function? See how up here it's the cube root of something? What did I put in there? It's not just a plain old x. What's subbed in that spot? Yeah, and which would be defined as well.
Oh, x squared plus 1.
And is that going to be continuous? Yeah, it's a quad. Are parabolas ever discontinuous? Yeah. So as I'm listing this out, the cube root function exists everywhere. The inside function exists everywhere. What do we know about our graph then? Yeah. The f of x function is continuous because in this case, I define the outside function as the cube root 1, and then I plugged into it this g of x, which is your quad. Both of those pieces are continuous. So is the original going to be continuous? The answer should be yes. That one's a little bit tougher to see, though. And it's a little bit awkward. We have questions on that? This next one is going to be more difficult. Let's start off by looking at what we have You've got two functions. What do you want the outside function to be? Take a look at what's there. There's two functions given to you in that second example on the right. What do you want your outside function to be, and what do you want your inside one to be? Look at what's there. What do you want your outside function to be? And then your inside function would be what? So let's go in and say that's my outside function and this is my inside function. Is the fourth root a continuous function? Why or why not? You can add to that. Think about it for a minute. It's the fourth root of something, so you're saying when I plug in a number, what times itself 4 times will yield this value? Like, where am I getting information? We've got one of us who can look at that. Is the fourth root of x going to be continuous? You're correct. You know why? You get what? Your argument in this case, and if you don't know the term, does anybody remember? Some of you that I've had, boy, I hope you remember this. What's the name of the expression under the radical calc? Does anyone remember? It's possible to call it the argument. The argument is a generic term for anywhere there's an input. Underneath the radical, whatever's in that spot has a specific name. What's living in that radical house? What's the name of what's underneath? I got 2, not bad. 3. You believe you took a year off from using the correct language? Thank you. It's called a radicand. You can't get a negative radicand value. You can't have a negative argument, a negative input. What would the domain of the h of x be? Do you know what it would be? Who knows what the domain of that's going to be? She was absolutely right in excluding some value. 0 to infinity, does 0 give you an output? And you take, can you figure out a number that times itself 4 times gives you 0? It shouldn't be that hard. What times itself 4 times gives you 0? Thank you. Now, so we know it's continuous above 0. Now, what about our quad? Is that going to be continuous? Peyton, what would you say? Yeah. Now, our purpose, now this is where it's going to get a little bit weird. We have to go through and take into account this function is going to be continuous everywhere the input for this expression is bigger than 0. Now, I'll even go through and do this. You've got x squared minus x minus 6. We need this to be, what was it, greater than or equal to 0? In order for this to work, that would be our domain. How can I solve that out? Well, easiest way to do it. I don't know if they did quad inequalities with you. How about you just solve it like this? So we're going to do some heavy hitting right now. Going to solve out that quadratic. Sabrina, what would you do in order to solve out this quadratic? Factor it down. Do you know what the factors do? After we've gone through and factored it, Marissa, what's your next step going to be? We factored our quad down. Yeah, so would you write out? Right, and? So we get critical values at x equals 3 and x equals -2. Now, there may be some sort of garbage gimmick that you have learned where there's like, oh, if it does this, you sing songs or something like that. I don't know. Here's an idea. You want to solve something out, just try it. Like you found critical values at at -2 and 3. How do we figure out if the inequality is true over here, here, and here? Try plugging in a test value. What's a number? Let's pick the easiest part. Look towards the center here on this number line. What's a test value in the middle region that you might be comfortable with plugging in and getting an output value for in the original inequality from above. I'm connecting this down to here. What's a test value in that center region that you might be able to even handle, dare I say, without a calc? 0. So when you plug a 0 in, you get 0 squared minus 0 minus 6. Is that greater than or equal? Well, what's the left side going to be, Joe, if you plug in a 0? What would this be if I plugged in a 0? Is negative 6 greater than or equal to 0? No. So does the inside region work there? No. So I'm going to put an F there for false. Now, go out on the right or left-hand side. Work at which side do you want to go? Do you want to go to the right or left? Okay. If you're trying to go through and show that that's, greater than 0, pick a test value over on the right. In this right-hand region over here, 4. So go in right now. You can use the calculator if you need it. 4 squared minus 4 minus 6. You need the math. 4 squared, 16 minus 4 minus 6 is the same as minus 10. 16 minus 10 is 6. Is 6 greater than 0? Yes. And the other region on the left will work if we did a test point as well. So which values are true? What's the domain of this? Well, the domain is anywhere from negative infinity to negative 2, and then from 3 out to positive infinity. And are the boundary values, do they satisfy when it equals 0? 0 equals 0, so yes. That would be the domain that it's continuous on. Where is this function then? I guess here's what I wrote down for it. The function itself is continuous over the interval we stated out, where g of x is greater than 0. Because the only problem that we had was when our radicand was negative. You can't take the fourth root of a negative value. So our argument or radicand can't be negative. That's why we went through and did all of that work with the quad and the quad and the quad. So if you were to go through and graph out this function, you'd see that it is not continuous over that interval. I don't think that that's too bad. Now, this is where I got a little bit lost. I think they stopped. Yeah, for some reason. Actually, here. Maybe it's not. Okay. So I think we can actually handle this part now. Where's take a look right now on page 21 at the top. So I'm going to have to bounce forward. Take a look at 21 at the top. See how it's got question number 6 there? Thought we would have this sheet, but apparently we don't. So this one right here, go in right now and answer out question 6. It's on the top of page 21. Go in right now and answer out 6 to the best of your abilities. 3. Make sure, please, you're referencing the continuity conditions in your definition. Did we get that it was continuous there? Yes or no? Is that difficult? Now, I think, has everyone in here, by the way, taken that quiz on 2.1 and 2.2? Anybody who has not taken it? Oh, you'll have to come in and go through. Was that last class that we took it, or 2 classes? I can't even tell. It was at the beginning. Okay, so you guys will have to come in sooner rather than later, but because there was an assessment too, so there were 2 things technically that you guys will miss. You can go through. I would hand, but the grades are in there. Slide over to the front. What do we got? Take a look. I guess our last one for today. When you came in a couple of days ago, remember you picked up 3 sheets? 3 or 4 sheets. There were limit worksheet A, B, and C. Now, your task is going to be, the last one on this group is limits worksheet C. So take that one out. It looks like this. Have it out on your desk. Hold it up like this so we can all see and make sure we're on the same page. It's got, I think, 5 questions on it. Some of what you've been able to go through and get done, some of that we should be able to go through and answer. I'd say questions right away like 1B, 1C, those are pretty straight up. What does that F with the little -1 after it mean? Inverse, we should know how to go through and take the inverse of a function. Find the domain and range of the different functions. On the back, you've got one about evaluating out some limits on a closed interval. You will not be able to do 4 until tomorrow, but you actually can go through, you've even got a minute or 2. Question 3 on that limits worksheet C is the same, or at least similar to ones that we've done in here to start things off. How would we show it's continuous at -3? What would we need to do to figure out what would make that function, I guess, continuous? Well, got to show your limit from the left, limit from the right, and so on. Okay. So I'd advise you minimally tonight get probably half of this done. Get the stuff you can handle tonight, because we're going to have this one. I think we may collect from you all. I'm not sold yet. Depends on whether or not we'll try to. If not collect it, we'll give you questions that are strikingly similar on a quiz coming up very soon. Just so you know, too, your continuity quiz is not next class, but the one after. You don't have school this Friday, no. So it's going to be on Tuesdays. I think you have a 4-day week. Yeah. The Math Excel is due the day that you guys take your unit exam. So, no. Make sure, though, you're keeping up with them. Like, you should be up to, what are questions? Should be up to, like, 29 or something like that? 39-ish, wherever it says on the right. The questions are sort of indexed by day. You guys did a great job today. Thank you very much. Was your assessment tough this morning? Let's hope not. Let's hope not. Maybe we'll make some casual mistakes which we can get over. But once everybody comes in and gets their stuff done, we can hand those back. I think we had 3 or 4 perfect papers already. And by the way, some of you that have had before, I've had the biggest dilemma for years with these stupid fish. I like to give you guys an acknowledgement if you did well, But the problem was, I had somebody come in and they did an amazing job on the sea of success, but then nothing would stick to it. So literally all the fish were around it, like a dead zone was the sea of success. I think we can actually put your fishies inside this year. So keep it up, thank you. Do your best, guys. So far, so good. The tape I have no issue with. It's this stupid computer.
It was just about to.
I know. Oh.